So for this question, we're modelling the ball as we're moving it through a tennis match. So if we imagine a tennis match, the ball kind of goes back and forth in this direction. So we would imagine it to have some sort of curved shape. We're told that X is the number of seconds after the ball has hit the racket, and Y is the height of the tennis ball. So as you hit the tennis ball, we expect it to kind of go up and then back down again. So we're going to draw a sketch of it, and to do that, we're going to use our calculator. So we're going to go to Y equals, and we're going to type in the function. So we need to make sure we use this bottom button next to the enter for the minus. So it's 6x squared plus 36x. And if we go to the graph, we can see roughly what this looks like. It looks like we need to make the y-axis a bit taller and the x-axis could be a lot smaller. So I'm going to change this to 30. And let's make the y-axis a little bit taller there. Okay, perfect. We could actually change this again. Let's maybe go to 15. There we go. So we can really start and see what's happening there a little bit clearer now. There we go. So we can see what's happening quite clearly. So we need to sketch this into our exam paper. So we have our two axes, and we know that we're really only interested in the positive part, which is why I've drawn the axis like this. So I need to find where my intersections are. So I'm going to do second function calculator, and it's the 0. Okay, so I'm interested in finding the one down here. So there's one down on this bottom part here. So I'm going to click above it and click below it. And I'm just pressing enter each time, and then it finds the middle value. So 6 is where it crosses my axis. It looks like it goes through the origin, but let's just double check. So 0, and this time we want to get close to it again. 1 above. And, whoops, let me do that again. Clicked the wrong button. So there we go. So I want 1 to the left, always do the left one first, 1 to the right, and yes, it goes through the origin there. And then we should probably find the maximum point here. So second function trace, and it's a maximum on this curve. And again, it's asking at the bottom, you can see here, left bound, so we want something to the left of it, and then something to the right of it. And then if we hit enter, we find that middle value. And it's at 3, which makes sense because it's symmetrical, and it's at the value 54. So 3, 54. And then I can draw my curve in, coming through. I do need to make sure my axis is labelled. So in this one, it's just X and Y. Always double check in a real life because it could be something different. And then how long does it take the ball to hit the ground? Well, it takes the ball 6 seconds. And we can see that because it's what we have just here. We hit the ball, it goes in the air, and then it comes back down and hits the ground 6 seconds later. So 6 seconds, and we need to give a reason. It says, how can you tell? And it's because that's where it falls back to the x-axis. So the function crosses the x-axis. Okay. And then the next question, what is the highest point reached? Well, the highest point is 54. And we're told that this is in feet, so 54 feet, which is the height it reaches here. Okay, and it does that in 3 seconds. So the highest it reaches is 54 feet, and we can see that because it's just the maximum point. And then when was the ball equal to or higher than 48 feet off the ground? So 48 is probably somewhere around here. And I'm interested in knowing at what time was it higher. So this part of the curve here that I've shaded. So to do this, I'm going to go back to my y equals on my calculator, and I'm going to type a new function, and I'm this time just going to put 48. And that draws my line across for 48. And then I want to find what are the times here and here. So to do that, I'm doing second function trace, and I want to find the intersections. So let's do the left-hand side first. So the first curve is the curve, then the line, and there's an intersection there at 2. So 2 seconds. And then I want to do the same thing again. So intersect, and let's go towards it. So I have the curve and the line, and there's a value there at 4. So that tells us that there are 2 places. So it's between 2 and 4. So at 2 and 4, it's equal to 48. And in between 2 and 4, it's more than 48 or equal to. And it says equal to or higher than. So it's between 2 and 4. Or you could write it as an inequality as 2 and 4. Okay, but you can also just write between 2 and 4 or in between 2 and 4, which is where the graph is higher. So all these points here, if you imagine, the x values are all between 2 and 4, which is how we've then calculated that one.